Hello everyone, welcome back to my channel. In today's video, I'm gonna still continue on the topic of water network synthesis. And if you remember, last couple of weeks, we have in our part one of the videos, we have completed our water pinch analysis diagram. And in this week video, we're gonna try to interpret the graph and then see and then based on our interpretation we will try to create our water network in order to minimize water usage in the tire to fuel processes. So yeah, without further ado, let's begin. All right, just to recap, if you remember last couple of weeks video, we are our task is very simple. We would like to perform WPA here, water pinch analysis. So we're going to perform water pinch analysis on tire to fuel processes. So to summarize, we have a scrap tires and it undergoes a pyrolysis process where these scrap tires will be converted into gaseous and liquid fuel using the thermal processes. If you want to check, if you want to get more details on this topic, please refer to these papers published in 1999 by Nurul Eddin and Al-Hawagi. Professor Hawagi here is from Texas A&M University, it's basically university where I studied for my PhDs. All right. Anyway, this is still a recap. If you remember last time, this is our process flow, the default, not default, the original one, where last couple of weeks, we have identified what is our source and what is our sink. And then we have identified two source and two sink. So we have SK1 here, and then SK2. Basically, SK1 and SK2. Uh, uh, it, One way for you to look at this is they are incoming what is called a process stream, and then we also have a source. No, a source is basically outlet of a process stream, but they are terminated. Okay, they are not being sent to another process. So you have SR1 and then SR2. SR2 is not cannot be seen because it is my videos are covering this process stream, but you know what I mean. And then, of course, in order for you to reuse all of the water, right, for water network synthesis, obviously you cannot get a pure water. You have to accept the fact that they will have impurities. So these are all of the impurities. Seal pot feed water is basically this one, SK2. Water jet makeup stream, impurities of 50 ppm is this one. Decanter wastewater is, let's see, maybe this one, 500 ppm. And then seal pot wastewater is 200 ppm. So we have covered this last couple of weeks, so I don't want to go into details. All right, as you can see here, this is our plot that we have created last couple of weeks. Now, yes, to create the plot is quite straightforward, but the question here is how can we interpret this plot in order for us to design our water network? All right, first thing first, this is basically my version of how I solve things. Maybe you have a different ways, maybe different professors have different ways of interpreting this, or maybe their step-by-step method are slightly different. But whatever, I mean, it comes to a same final answer. All right, so this is the plot. The first thing that I often interpret here is what is my pinch. Pinch is basically a point where the source, no, the sink touches one of the source diagram. Now in this case, okay, the point here is 0.18 kilogram per second, and the impurity here is around how was it 9, probably 20 something. Okay, it's 20 something. It's typo here, it's 20 something milligram per second. Now that's number one. What's your pinch? Number two is, okay, what is the pinch causing source? So if you see here, this segment belongs to SR1. So the pinch causing source is SR1. That's number one. Number two, number three is you need to know what is the fresh water recovery and wastewater generated. So fresh water that is needed, recovery, basically how much water that you can recycle, and then what's the wastewater, and how can we calculate those? It's quite simple. Now, if you see here, there are only two curve with two colors, right? The first one is the blue colors, and the second one is the red colors. So to find out what's the wastewater, just find a point where it only have one line. This is only have one line, which is the blue line, right? So you create a kind of a vertical line. That's one. So this is considered a freshwater region because it only has one line. Now, for the wastewater one, you also find a region where it only have one curve. In this case, it should be a red curve. So it begins from here, this point, all the way to the end of this point. Now, anything in between that has two curve, you see here, one curve, basically two colors, blue and red. Those are basically how much water that you can recover. So the question here is, how can you calculate the amount of fresh water that you need, right? It's quite simple. So in here, right, you have 0.135 minus 0, as simple as that. So the amount of fresh water that you need to provide is 0.135 kilogram per second. Now, how about recovery? Recovery here is basically a vertical distance between this point to this point. So basically, a vertical distance that has two curves on it. So in this case, I have 0.28, and in here the other region is the other end would be 0.135. So 0.28 minus 0.135 is 2665 kilogram per second of the amount of water that you can recycle. And then wastewater is quite simple, the same thing from this vertical line uh, to this vertical line. So from this vertical line, this is 0.435. The other end is 0.28. So 0.435 minus 0.28 is 0.11155. All right. So from this plot, what can you get? Okay, I would like to recap. The first one here is you can tell what is the pinch. Pinch here is 0.18 kilogram per second of fluid, and then these are 20 something. These are not 9, 20 something milligram per second of impurity. Those are your pinch. Now, what's your pinch causing source? Basically, this point belong to which segment? This is SR1. So pinch causing source is SR1. Now, amount of fresh water that you need to provide is 0.135. The amount of water that you can recover or recycle is 2665 kilogram per second, and then wastewater is 0.155 kilogram per second. So that's the first thing that I would interpret for this plot. Now, what are the other things that I can get, right? Obviously, you can refer to the next column here. Okay, as you can see from the pinch point to the end of the whatever line, uh, to the end of your pinch causing source, end of it, from the middle here to here, these are called fluid or to high quality region. So 0.18 minus this 0.135. So I got 0.045 kilogram per second. These are flow rate from high quality region. Now, do the same. These are flow rate from low quality region. Why on the right side low quality region is because from here from left to right the impurity load increases, so the quality basically decreases. So this one is not for is from the pinch causing source only. So just this point to the end of the pinch causing source. You have to remember that because later this one is a very simple examples where you only have two segment, but maybe you have like 100 segments. So you just need to find from the pinch to the end of your pinch causing source. You have FHQR and FLQR. So those are the first thing that I would provide information from the plot, which is quite okay, which is quite straightforward. But the next question here is, um, yeah, I know in summary what's my recovery, what's my fresh water, and what's my wastewater. But the next question here that I need to answer is, how much need to be sent to a particular unit, all right? So that's the question. So how can I solve this? All right. So what I need to do next is quite simple. This graph, what I will do is whatever point here, I do a vertical line. So here point, 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 and then this point, and obviously I have another point here. So create a vertical line that crosses this each of these points. Whatever point you have, if you have 100 point, do a vertical line. Now, based on this, how can I interpret this one? Okay, it's quite simple. You just need to know what is the distance between here to here, and then what is the source and what is the sink. Now, I would interpret from left to right. Now, in this case, it's quite simple. All right. Um, so if your what is it called? If your plot on no if this particular region only have one line, means that either it is a wastewater or fresh water. Now in this case, right, I only have one plot from here to here. I only have one line, blue line, which is basically SK1. So the amount that I need to the amount of fresh water that I need to provide to SK1 is from here minus here. So 0.135 minus 0 is 0.135 kilogram per second. So this is the amount of fresh water that I need to provide to SK1, because as you can see, this only have one what is called one plot. Okay, okay. I'll give another example so that you can see. Now I go to the other side, the other extreme. Now in this case, this region from here to here, I only have one line, and it coming from source, right? Source always has a wastewater. Now in this case, how much wastewater that will be generated is between here to here. So it's around let's see 0.28 until 0.435. So 0.435 minus 0.28 is 0.11155. But so I'm generating 0.155 kilogram per second of wastewater, but they are coming from SR2. So SR2 is generating 0.155 kilogram per second of wastewater. Now, fresh water need to be supplied to SK1, which we'll see later, and it is 0.135. Now, how about anything in between? So I'll solve this one first. Now, for this one, I have what is called, I have two plot here, right? Two segment. Number one here is this blue line. This is the red line. Now, this blue line is SK1. This red line is SR1, right? Now, how can I interpret this? So basically, sum of sum of SR1, because SR1 is from here to here, right? So from here to here is sum of it. Okay, sum of it. Sum of SR1 goes to, what is the plot? What's this blue line here? Belong to SK1. So sum of SR1 goes to SK1. So 0.18 minus 0.135, I get 0.045 kilogram per second of SR1 go to SK1. Now, remaining of the SK1, because these are the remainder of SK1, goes to SK2. So these are SK2. Okay, these are SK2. Remainder, right? These are the whole line length. So some of it goes to SK1. The remainder goes to SK2. Now the amount is 0.28 minus 0. Let's see, 0.235, I'm sorry, minus 0.18, 0.055. Now you go to the next section here. Now this segment belongs to SR1, no, SR2, and this segment belongs to SK2. Now this is the whole segment. So from here to here is only sum of it. Okay. Now what I will do is sum of SR2. So sum of SR2 goes to SK2. So the amount is 0.28 minus 0.235, 0.05. Now the remainder of SR2 just go to wastewater, as we have discussed earlier. So that's how I interpret this. Based on this text, you can easily modify your process flow diagram. So uh, we check out our process flow diagram. Okay, This is the original one. I know SK1 here, SK2 here, SR1 here, SR2. Now, our first sentence is fresh water to SK1. Now, fresh water to SK1 is this. You just create a new line if you want, and then the amount is 0.135. Quite straightforward. We already identify SK1 is going here, right? Just create a line going here, 0.135. Okay, done. What's the next text? Sum of SR1 go to SK1, right? So in this case, sum of SR1, right? So you find out what is SR1. These are SR1. Sum of it, you create a line. Basically, just create a junction, goes to SK1. So these are SK1. So sum of it go to SK1. The amount is 0.05. Now the remainder of SL1 goes to SK2. These are SK2. So here, just go all the way to here, and the amount of 0.055 kilogram per second. Now you check the next text. Sum of SL2 go to SK2. Now these are SL2. Sum of it. So these are sum of it. You create a junction, go to SK2. These are SK2. So you create like this. And the remaining, just go to wastewater. As simple as that. Now, this is how I interpret. And obviously, lastly, you need to clean up your process flow. This is how it looks like, where, fresh water is like this. Some of this go to being recycled back, some of this go to SK2, and some of it is being wastewater. Now, this number and this number, they should line up with your interpretation. Now, why do I need to clean up from drawing point of view? The horizontal line always more dominant than the vertical line. As you can see, there's a gap. There's one way where you can just create a jump, but I prefer to have it as like have a gap to indicate that these lines are not even connected. Well, that will be all for me. I hope you like the videos. Give it a thumbs up. Consider subscribing to my channel. I'm trying to get 1,000 subs, so please do subscribe. And I'll try to make a more nice video. And I'll see you maybe in next week or next couple of weeks videos. All right. Bye bye, and have a very nice day.